In this ecowest.org presentation, we discuss the progress made in cleaning up our air and the challenges that remain. The U.S. continues to make progress on improving its air quality since the Clean Air Act's enactment in 1970. This graph from the EPA's Air Trends website displays how regulations and advancements in technology have led to efficiency improvements, lower emissions, and cleaner air. While the economy, the GDP, has continued to grow, the aggregate emissions from the major criteria pollutants that EPA regulates have shrunk by 60% since 1990. Here's a closer look at national trends by each pollutant since 1990. The greatest progress is seen in sulfur dioxide, a major precursor to acid rain. Sulfur dioxide has diminished largely due to emission scrubbers on power plants and advancements in manufacturing lower sulfur fuels. Progress is less substantial on ozone and fine particulate matter, or PM2.5. A significant challenge with ozone and PM2.5 are their precursors. Put simply, pollutants are either created directly by emission sources like power plants or indirectly when precursor pollutants mix together in the atmosphere and chemically react to form a new pollutant. PM2.5 is emitted during combustion, but it also forms in the atmosphere when volatile organic compounds, nitrogen dioxide, and sulfur dioxide chemically react. Here we only focus on direct emissions, and therefore do not cover ozone. However, ozone's precursor pollutants are discussed. This graphic shows how air quality changed between 1980 and 2010, and between 2000 and 2010. There is no data for particulates in 1980. You can see that all of the major air pollutants have declined in recent decades. Here's a slightly different way of looking at the issue, the emission sources responsible for each of the pollutants. Once again, there have been dramatic improvements in recent decades. Although the nation's air quality is clearly improving, tens of millions of Americans are still exposed to unhealthy air. In total, about 124 million people lived in counties that exceeded one or more federal health standards. This map shows the estimated cancer risk by census tract. In the West, areas around big cities such as Los Angeles, Phoenix, Denver, and Portland have higher rates of cancer associated with toxic air pollutants. This map shows how many days on which a city's air quality index exceeded 100, a level at which pollution can be unhealthy for sensitive groups. Los Angeles stands out as the western city with the worst air pollution, while Seattle and Portland in the Pacific Northwest have relatively few bad air days. In general, the number of bad air days has been decreasing over the past decade. Let's take a look at the sources of air pollution, beginning with those that directly emit particulate matter, or PM2.5. As you can see, not all states are equal contributors, and the source profiles by state also vary. California, the 8th largest economy in the world and most populous state in the country, is not surprisingly the largest polluter. Within California, the sources are relatively evenly distributed. Note that fire and dust were significant in 2008. From 2007 to 2009, California was in a drought. Overall, PM2.5 levels were higher in 2008 than in 2006, and the drought could have been a major reason why. Dust is also a major polluter in arid states like New Mexico. All other sources is made up of agriculture, industrial processes, solvents, and miscellaneous sources. Next, let's take a look at oxygens of nitrogen, or NOx. NOx is important because along with VOCs and carbon monoxide, it's a major precursor to ozone. Ozone, while a critical element in the upper atmosphere, is a pollutant at ground level, what we usually observe as smog. As you can see, California once again dwarfs the other states, and the primary culprit is mobile sources. This is the result of a large population doing a lot of driving in a sprawling state. There's also lots of industry serving those people, and California houses the largest ports in the United States. Ships, trucks, trains, and supporting equipment, along with a vast number of passenger cars, are the reason that California's NOx levels loom large over other western states. California has done better with sulfur dioxide. As you can see here, the largest states for sulfur dioxide emissions are Arizona, Colorado, and Wyoming. What these states have in common is coal. Coal power plants are the single largest source of anthropogenic sulfur dioxide. Wyoming not only gets 95% of its power from coal plants, it's also a major supplier of coal and is home to the Powder River Basin. If you look at Washington and California, mobile sources are 1/3 or more of sulfur dioxide emissions. Washington and California are not major coal-burning states, but they are home to significant marine ports. The large freight ships that carry containers of goods between the U.S. and Asia burn bunker fuel, which is inexpensive but very dirty and has a high sulfur content. Volatile organic compounds are important because they're a precursor to ozone and PM 2.5. They're emitted in many consumer goods such as cleaning fluids, paints, and printing inks, as well as industrial sources and fuels. Because they are in pesticides, agriculture can also be a significant source in some states like Idaho. Overall, volatile organic compounds are more of a concern for indoor than outdoor air quality. EPA has found that VOCs can be 2 to 5 times higher inside households than outside. Finally, carbon monoxide emissions have declined steeply, falling on average 80% below the national standard over the last 20 years due to advancements in vehicle technology and fuels. Although California remains the largest source for carbon monoxide in the West due to the large number of cars and trucks, it remains in compliance with the EPA standards. Thanks for watching this presentation. You can download more slides and other libraries at ecowest.org.